Icebergs are my absolute favorite YouTube format. The deeper we go in the iceberg, the more hidden and obscure the information becomes. So, hold on your breath, and also please subscribe if you haven't already, and down we go. Game logic. Game logic refers to the rules and algorithms that define how a video game operates. It encompasses everything from player input and character movement to win conditions and AI behavior. Game logic is crucial for creating interactive and engaging gameplay experiences. Classes and object-oriented programming. In game development, object-oriented programming is a programming paradigm that uses classes to define objects and their behaviors. Classes act as blueprints for creating objects, allowing you to encapsulate data and methods together. This approach promotes code organization, reusability, and modularity, making it easier to manage complex game systems. Encapsulation. Encapsulation is one of the principles of object-oriented programming. It involves bundling data and the methods that operate on that data into a single unit called a class. This unit can hide its internal implementation details and expose a controlled interface to the outside world. Encapsulation helps manage complexity, enhance security, and promote code maintenance. Calling engine functions. Game engines like Unity or the Unreal Engine provide a set of predefined functions that developers can call to perform various tasks. Calling engine functions allows developers to leverage the engine's built-in capabilities for tasks such as rendering, physics simulation, and input handling. It streamlines game development by providing a standardized way to interact with the engine's features. State machines. State machines are design patterns used to manage the different states a game or game object can be in. States represent specific behaviors or conditions, and transitions between states define how an entity responds to its events. State machines are essential for controlling character behavior, game flow, and AI decision-making. Procedural generation. Procedural generation is a technique used to create game content such as levels, terrain, or textures algorithmically rather than manually designing each element. It enables developers to generate vast and diverse game worlds dynamically, enhancing replayability and reducing content creation efforts. I think most people will have heard of procedural generation in relation with the No Man's Sky video game, where it's used to create infinite worlds. A similar concept to it is fractals or fractal algorithms, where a fixed set of rules is applied in an infinite loop, graphically resulting in awesome motifs like the infamous Mandelbrot set. Singleton pattern. The singleton pattern is a design pattern that restricts the instantiation of a class to one single instance. It ensures that there is only one global point of exit of that instance. Singletons are often used for centralized management systems like game managers, input handlers, or resource managers. Pathfinding. Pathfinding is the process of finding the optimal path from one location to another within a game world. It's crucial for AI navigation, ensuring that characters or objects can move intelligently and efficiently in response to player comments or AI goals. Popular pathfinding algorithms include A** and Dijkstra's algorithm. Vector math. Vector math involves mathematical operations performed on vectors, which are quantities with both magnitude and direction. In game development, vector math is used extensively for tasks like character movement, physics simulations, and graphics transformations. It plays a fundamental role in representing and manipulating spatial information. Interpolation function. Interpolation is the process of estimating intermediate values between two known data points. In game development, interpolation functions are used for smooth transitions and animations. They calculate intermediate positions, colors, or other attributes to achieve visually pleasing effects, such as smooth character movement or fading in. Shaders. Shaders are programs used in computer graphics to control how objects are rendered. They define the appearance of materials and lighting calculations and create visual effects. Shaders are essential for achieving realistic graphics in games, and they run on the GPU. Entity component. Entity component is an architectural pattern in game development that separates game objects into collections of components. Components encapsulate specific functionalities, like rendering or physics, and can be mixed and matched to create diverse game objects. This approach promotes code reusability and flexibility. Sequencing patterns. Sequencing patterns in game development are design patterns that help manage the flow and order of game events, actions, or interactions. They define how the different parts of the game communicate and coordinate to create coherent gameplay experiences. Object pooling. Object pooling is a memory optimization technique where a predefined number of game objects are created and reused instead of instantiating and destroying objects frequently. It improves performance by reducing the overhead of object creation and garbage collection. Decoupling. Decoupling is a design principle aimed at reducing dependencies between different parts of the code. By minimizing interdependencies, game developers can make their systems more modular and easier to maintain and extend. Mesh generation. Mesh generation involves creating 3D surfaces and modules programmatically. It's used for design, terrain generation, and procedural content generation, allowing developers to create complex geometry efficiently. Fluid simulation. Fluid simulation techniques are used to mimic the behavior of fluids like water, smoke, or fire within games. These simulations provide realistic interactions and visual effects, enhancing the immersion and realism of a game. Custom physics. Custom physics refers to the implementation of physics systems tailored to a specific game's requirements. This may involve creating custom collision detection and response algorithms or modifying existing physics engines. Memory management. Memory management in game development involves efficiently allocating and deallocating memory to optimize a game's performance and prevent memory leaks. It's crucial for maintaining stable and responsive gameplay. Entity component system. Entity component systems are an architectural pattern that separates game entities into 3 core components: entities themselves, components, and systems. This approach is designed for high-performance game development and can improve parallel processing and scalability. Custom 3D renderer. Creating a custom 3D renderer involves building a graphics rendering engine from scratch or extensively modifying an existing one. This is often done to achieve unique visual effects or to optimize rendering for game-specific requirements. Custom networking. Custom networking refers to the development of a network communication system tailored to a specific game's multiplayer needs. It allows developers to implement unique networking features and optimizations. Raytracing. Raytracing is a rendering technique that simulates the path of light rays to create highly realistic lighting, reflections, and shadows. It's known for its ability to produce photorealistic graphics. Extreme optimization. Extreme optimization involves fine-tuning and optimizing code and algorithms to achieve the highest possible performance. It often requires in-depth knowledge of hardware and software interactions. Vulkan. Vulkan is a low-level graphics API designed for high-performance 3D rendering. It provides developers with greater control over graphics hardware, enabling advanced graphics applications. Client-side prediction. In online multiplayer games, client-side prediction is a technique where the client predicts game states to reduce perceived lag. It helps maintain smooth gameplay experiences in the presence of network latency. Assembly. Assembly is a low-level programming language used for performance-critical parts of games or engine development. It allows developers to write code that directly interfaces with hardware. Non-euclidean geometry is a mathematical concept used in game design to create surreal or abstract game environments that do not adhere to the rules of traditional Euclidean geometry. Euclidean geometry includes a set of basic rules for vector spaces, with them resulting in some mathematical rules, like the angle sum of triangles always being 180 degrees, or the Pythagorean theorem. Anti-cheat. Anti-cheat measures and techniques are implemented in online games to prevent cheating or unauthorized modifications. They help maintain fair and competitive gameplay environments. GPU assembly. GPU assembly involves writing code specifically for the graphics processing unit. It's used for highly specialized graphics effects, custom shaders, and optimizations targeting the GPU's capabilities. So, that was my first Iceberg video, and if you liked it, there are extended versions of my videos available for all of our tiers on Patreon. Now, what are your thoughts on game development? Did I miss anything? Please feel free to let me hear in the comments, and I'll catch you in the next video.